So here's our example of three disjoint events, E, F, and G, indicated by these pink circles here. You notice they don't overlap, they don't share any outcomes. That's what you need for them to be disjoint. So when they're disjoint like that, the event E or F or G is just a list of all the outcomes that belong to either E or F or G. So all the ones in E and all the ones in F and all the ones in G together. So 3 of those, 2 of those, 2 of those go in there. And since there's 10 altogether, and there's 7 in the event, the chance of picking one of those 7 is 7 out of 10. And then if we look at the probabilities separately, well, it's just going to be the number of events divided by, number of outcomes divided by 10 for each. So 3 tenths, 2 tenths, and 2 tenths, 3 tenths, 2 tenths, and 2 tenths. You know 3 tenths and 2 tenths and 2 tenths is 7 tenths. So the 7 tenths is equal to the sum of the probabilities of E, F, and G separately. So that kind of makes a lot of sense in those easy cases, and it's just true in general. If you have disjoint events, to find the probability of the union, you sum the probabilities of the individual events separately. So here's another example of that. Randomly select one card from a deck of 52 cards. The cards are ordinarily labeled ace through king, so there's 13 kinds of cards. And then each of those cards has a suit of one of 4 types. So 13 cards, each assigned a suit as either spades, hearts, clubs, or diamonds. So it's 13 times 4 actual kinds of cards, which is 52. And you have that diagram of those cards on your handout, which helps. I'm not going to try to draw that. We have some events. The first event is draw a king. There's 4 kings. One king is one of the 13 kinds of cards, and it appears in 4 different suits: king of spades, kings of hearts, king of clubs, king of diamonds. So there's 4 kings. And 52 total cards. You're selecting one at random, so each has chance 1 on 52. 4 of them gives you 452. So the same thing would happen for queens and jacks. They'd all be 452s. So the chance of drawing a face card would be the chance of drawing a face card would be E or F or G. If E is king, F is queen, G is jack. E or F or G, those are all the face cards: king, queen, jack. So the probability of drawing a face card is the probability of E or F or G. And our rule says we can get that probability by summing the probabilities separately. Each of them is 450 seconds. And so the total there would be 1250 seconds, which would be the number of cards is 12 face cards, divided by the total number of cards, which is 52. So once again, verifying that rule for disjoint events, the probability of the union is the sum of the probabilities. So what about events that aren't disjoint? Here's the general addition rule. The probability for E or F, and this works even if they are disjoint, but as a general rule, it works for any events E and F. You take E's and F's probability, and then you subtract off the probability of E and F. So that corresponds to more or less the same thing as counting. If you have E here having 4 elements, E has 1, 2, 3, 4, 5, and F has 1, 2, 3, 4 like that, and they share 2. Then to get the total number of outcomes in E or F, you're going to take the ones in E plus the ones in F and subtract off the double count, so the ones that are in both. So that'd be 4 plus 5 minus 2. When you do that in probability terms, then you'd have 7, 1, 2, 3, 4, 5, 6, 7 in the union. So the probability E or F would be 7 tenths. You have 2 in the AND, so AND has to belong to both. That's the intersection. There's 2 elements of the outcomes, 2 outcomes in E and F. So if you take the probability for AE, which is 5 tenths, and F, which is 4 tenths, you'll be double counting these outcomes here because they belong to both in the union. And so you're going to have to subtract off the 2 tenths to get the right answer. And that's all this thing says here. So probably E or F is E plus F minus the probability of E and F. So sometimes that's drawn, and that has actual outcomes in it. Ordinarily, you might see a picture that looks like this. Just more abstractly, E, F, S. And then you'd say to yourself, with shading maybe, the probability for E would be summing the probabilities of the outcomes in here. the probability for F would be summing the outcomes of the probabilities of the outcomes in here. And if you just add those two probabilities together, you're going to add the probabilities for the E and F outcomes in there 2 times. And so to get the right answer, you just want this region plus this region's worth of outcomes, their probabilities added together. You have to take the ones that are in both. You count it 3 times if you do this one plus this one. And so you have to subtract it off. So that explains the probability E plus the probability F minus the probability E and F, giving the probability of E or F. Okay, so let's see what I've got left here. There must be something coming up that oh, we got the complement rule. I forgot about that. We talked about complements up front there. And so we'll be doing the complement rule and one more example of the general addition rule on the next slide. And I'll see you in a minute.